Calculus BC, Lesson 5.4, our second part. We're picking back up with this graph of a velocity function. And you can see right in here in green, we know that velocity is positive here. And that would indicate that we're traveling to the right. What this really means, of course, is this green portion is your distance traveled to the right. By way of comparison, we know that when velocity is negative, you're traveling to the left. So if you looked at this yellow region right here, this would indicate distance traveled to the left. And we could work that out. We could, either through the fundamental theorem, or either we're told this or we use some geometry. Let's just say that in green we have a positive 6 right here. Over here we'd have a negative 4 for our yellow area. Remember, we have signed area. So if we were to integrate, if we were going from a beginning x value or time value of a and an ending time value of b, and if we were to integrate velocity, we just said before that integrating velocity on a definite integral is displacement. It's the change in position. Well, imagine that you're traveling 6 units to the right and then you're traveling 4 units to the left. Well, putting that together, if you were to add that, you'd get 2. And in other words, there's more positive area. You're saying that you'd end up 2 steps to the right, or 2 units to the right of where you began. Likewise, if we would have had a negative integral here, a negative displacement, that would indicate that you end 2 units to the left of where you began. That does beg the question, though, that displacement is how you're changing, the change in position from when you started. Total distance traveled, by the way, the word total isn't even needed, honestly. You could just call it distance traveled. What you have to do is envision that you're integrating everything in absolute value. This would be, well, you have 6 steps to the left, you've got 4 steps to the right, but don't have the sign of negative any longer. This would be 10 units of travel altogether if that were the case. So if you're going to work out total distance traveled, find out where you have negative area, convert it to positive area, and then add it together. With displacement, honestly, you don't even have to find out where your curve is going to be positive and negative. You could just work it out directly. Our last problem is going to bring into play these 2 major ideas, displacement and also distance traveled. So let's do example A here. A particle moves along a line on the time interval from 1 to 4. Its velocity is right here. So find the displacement. Well, we've just seen what displacement is. Displacement is the integral of velocity, and we're going to be integrating from 1 to 4. And what is our velocity function? Well, it's t squared minus t minus 6. And using the fundamental theorem of calculus, we'd go t to the third over 3 minus t squared over 2 minus 6t. And now what? Well, we're going to evaluate that between 4 and 1. First, we plug in our 4. We'd get 4 to the third over 3 minus 4 squared all over 2 minus 6 times 4, which is 24, minus, I think this is going to be a little easier, 1 to the third all over 3, that's just 1/3, minus here's your 1/2, and 6 times 1 is just that. Well, 4 to the third is 64. We'd have 64 over 3. 4 squared is 16, but divide by 2 and you'll get 8. And then 6 times 4 is 24. So we have 64 thirds minus 8 minus 24. But then, of course, we could, do one of 2 things. We could distribute that negative, or we could combine everything immediately. And It's completely up to you which way you want to do it. Look, sooner or later, you're going to have to combine like terms. With a 3 and a 2, let's get a common denominator of 6. This is going to be 2 6 minus 3 6 minus 36 sixths. And if we were to just combine everything in here, I think you can see pretty quickly 2 minus 3 is negative 1. Negative 1 minus 36 would get negative 37. So as you look at that minus a negative, well, my goodness, that's going to turn into plus a positive. So we can even change that pretty quickly. And, as we work this all out, let's see where we're going. You can pretty much see negative 8 minus 24. If we were to group these two things together, that, of course, is going to be negative 32. 64 plus 37. Well, and you can see I'm doing all of this by hand without use of a calculator. 64, well, you know what? Pardon me, we didn't get a common denominator here, did we? We'd have to multiply 2 over 2. Almost made a real silly arithmetic mistake there. That's 128 over 6 plus 37 over 6. And as we put those together, let's see, we have 5. That's a 6. I guess it's 165 all over 6, right? So from here, if we were to just get 32 to have a common denominator, if we multiplied by 6 over 6, this thing would become minus 192 all over 6. So from here, wow, we can pretty much just do some basic arithmetic. We can do 192 minus 165. Again, notice I'm not even using a calculator, whatsoever here. Let's see, 12 minus 5, of course, we're going to get 7, and this would be 27. So this would be negative 27 over 6. We should reduce, however. If we divide out a 3, we'd get negative 9 over 2, which is a decimal, would be negative 4.5. That's our displacement. The displacement being negative would mean that we are ending to the left of where we began, and we're ending negative 4.5 units to the left of where we began. That's all well and good. As we look at this last part of the problem, though, it says find the distance traveled. Now, velocity equaling t squared minus t minus 6. First things first, I want you to realize this factors. And it's going to factor into t minus 3, t plus 2. And if you're really thinking about it, you know that when a parabola has a lead coefficient that is positive, it's going to open upwards. So I'm going to make a real quick graph of velocity here. And I'm going to say that I've got a t-intercept at negative 2, also a t-intercept at 3. And I know I'm opening upwards. By the way, if I plugged in a 0 for t, I'd have a y-intercept at negative 6. Right now, I don't know exactly where the vertex is. I could figure it out pretty quickly, but we don't even need to do that, honestly. What I am knowing is that I'm going to be integrating from 1 to 3, and I would expect to get negative area because my velocity is below the time axis, and that indicates I'm traveling to the left. But then as we move over between 3 and 4, you can see right here, we would expect to actually get positive area. Now, when you're doing distance traveled, guys, you actually have to break it up in this regard. You can't just have one general integral. I'm going to say from 1 to 3, because I'm not starting at 0. I'm going from 1 to 3 of t squared minus t minus 6. And this is when we're below the velocity axis here, and we can put a little squiggle here. We're also going to have when we're above. When we're above, that's going to go from 3 to 4 of t squared minus t minus 6 dt. Now I know from the start, in green here, as I'm integrating from 1 to 3, I should get something negative. So I already took an antiderivative up above, so I'm quickly going to make note of that. And then we just have to crunch these numbers. I'm going to use the fundamental theorem and plug in a 3. 3 cubed is 27, and 27 divided by 3 is 9. Plug in a 3 here. 3 squared is 9. I'd get 9 over 2. And then 6 times 3 is 18. But then I'm going to minus the 1 cubed over 3. That's 1/3. I plug in the 1. I get minus 1/2. And then we've got our 6 times 1. That's over here. By the way, if that looks suspicious to you, if you say, wow, that seems so much like what we were just doing, you know what? You just did that work up above. You got negative 37 over 6 here. So we could take advantage of that. We could definitely say, hey, we already did that. By the way, from here, if you were to do 9 minus 18, that's negative 9, isn't it? Negative 9, if we just combine those two, minus 9 halves. And wow, this would be negative 18 over 2 minus 9 over 2. And then this is plus 37 over 6. So, as we keep going here, this is negative 27 all over 2. But if I wanted to get a common denominator by multiplying by a 3, I could easily do that. I could get negative 81 over 6. And, right here, if we just did 81 minus 37, just doing a whole bunch of work here, I think you get, 44. So you'd get a negative 44 over 6, or equivalently a negative 22 over 3. That right there, the fact that it's negative, is indicating that you're traveling 22 over 3 units to the left. But in total distance, you take the absolute value and make that positive, wouldn't you? Most definitely. Well, let's just think for a moment here as we're working this other part out. And we can get some help here. We can say, well, antiderivative, we get t cubed over 3 minus t squared over 2 minus 6t. And then we're going to evaluate between 4 and 3. And we'd get 4 cubed over 3 minus 4 squared over 2 minus 6 times 4. Then we'd say, wow, well, let's see. We're going to say minus, and then plugging in a 3. 3 cubed is 27. 27 over 3 is 9. 3 squared is 9. We get 9 over 2. And 3 times 6 is 18. And before you know it, you can look right here with what I've just written. You might say, now wait just a moment. You just took care of that right over here. You see what I'm saying? If you were to look earlier, you just did that exact calculation. You did all the work getting this common denominator. You wound up with negative 81 over 6. So you already did that work. You might say, wow, could we maybe luck out and see that we did something with the 4? You did earlier, if you think about it. When we were doing the displacement, this right here, the 4 cubed over 3 minus 4 squared over 2 minus 6 times 4, that really worked out as well, didn't it? Unfortunately, we did some combining, but when you look right here, this 64 over 3, that became your 128 over 6, and the minus 32, like if I just copy that down here, the 32 over 6 was that minus 192 over 6. If I'm not mistaken, I believe that would be a negative 64 over 6. This is all number crunching, really. But where are we going right now? Well,